All right, so you've got the basics of TypeScript down, but today we're going way beyond that. We're opening up the developer's toolbox to look at some of the real power tools, the things that let you build stronger, safer, and just smarter applications. Let's get into it.
Look, we all start with string and number. They're great. But the real world, it's messy. Data gets nested inside other data, things get complicated, and sometimes you have no idea what kind of information you're going to get from an API. That's exactly where the basics start to break down and where these power tools really start to shine. So, first up in our toolkit, let's talk about structure. When your data isn't just a simple value but has layers and complexity, you need a way to draw a really clear blueprint for it. This is all about defining and even combining those complex data shapes with total precision. The most fundamental way we build up complexity is with nested objects. It's a simple idea, right? For example, you might have a book object. It has a title, sure, but the author property, well, that can be an entire object itself, with its own properties like a first and last name. It's just a clean, organized object tucked inside another object. Okay, but here's where it gets really cool. We can reuse these blueprints. Let's say you have two totally separate interfaces. One describes a student, student ID, a name, and another one describes a teacher, with a teacher ID and name. Think of these as two distinct, reusable building blocks. So what happens when you have someone who's both a student and a teacher? Do you start from scratch and make a whole new interface? No way. You can just combine the existing blueprints using something called an intersection type. That little ampersand symbol, the and, is the magic here. It smashes them together, creating a new type that has all the properties of a student and all the properties of a teacher. It's a beautiful way to keep your code dry and reusable. All right, tool number 2. This one is all about dealing with uncertainty in your code. What do you do when you just don't know what a variable's type is going to be? This is a fork in the road for a lot of developers, a choice between taking a risk and playing it safe. On one side, you have any. Think of it as the Wild West of TypeScript. It basically tells the compiler, hey, look away, I got this. You can do literally anything with an any type, which feels powerful until your app crashes. On the other side, you have unknown. This is the safe, disciplined choice. It'll accept any value, just like any, but, and this is the key difference, it forces you to prove what type it is before you can do anything with it. So unknown makes you be responsible. And the source material had this quote that just nails the difference perfectly. It translates to any means anything, unknown means we don't know. And that is everything, isn't it? We don't know forces you to find out before you move forward. That single idea is the absolute heart of type safety. Okay, so we've talked about handling the complete unknown. But what about the total opposite? What about those times when you know exactly what the choices are, and it's a very small, predictable list? Well, we've got tools specifically for that too. First up, we have enums. The perfect example is a traffic light. You know it can only be red, green, or yellow. An enum lets you define that limited set of options. So you create your color enum, list the members, and then you can access them with a dot, like color.green. What's happening under the hood is TypeScript is just assigning a number to each one. So color.green is really just the number 1. It makes your code so much more readable and prevents typos you might get with plain strings. Next in this category are tuples. Now, these might look like regular arrays, but think of them as arrays with very strict rules. They have a fixed length, and they demand a specific type for each position. So this example, number, string, means it must have exactly 2 elements, and the first one must be a number, and the second must be a string. It's all about guaranteeing the structure of your data. Okay, for our last tool in the kit, let's bring some of these ideas into the thing we write all day, every day, functions. We're going to see how to make them more powerful, way more flexible, and of course, safer. So, remember our safe and responsible friend unknown? Well, here's where that safety can feel like it's getting in your way. If you have a variable that's unknown, TypeScript will throw up its hands and give you an error if you try to do something like check its length. It's stopping you because it can't guarantee it's a string. So, what do we do? The answer is a tool called typecasting. This is where you, the developer, step in and take charge. By putting string right before the variable, you are telling the compiler, listen, I know more than you right now. I am absolutely positive this is a string, so just trust me. It's a way to override the compiler's safety check, but you have to be sure you're right. And just like that, the error is gone. Now let's talk about making functions more flexible. How many times have you had a function where one of the arguments isn't always needed? Well, TypeScript makes this super easy. All you do is add a little question mark after the parameter's name, like last name, ? And just like that, you've made it optional.
And what that means is you can now call your buildName function with just the first name, and it's totally valid. Or you can call it with both the first and last name, and that's also perfectly valid. That one little ? gives your functions a whole new level of flexibility, which is just awesome.
So there you have it. We've just added 4 major power tools to your TypeScript toolkit. And these aren't just academic ideas. These are real, practical things you can use to start building your code with way more confidence. So let's do a super quick recap of what you've learned. You now know how to combine types with that and symbol. You know to always reach for the safety of unknown over the danger of any. You can define those fixed lists of options with enums and tuples, and you can make your functions way more powerful with typecasting and optional parameters.
And why does any of this matter? What's the payoff? It's simple. You get better code. Code with fewer of those awful runtime errors that crash everything. Code that's more predictable and easier for your future self and your teammates to understand. It's basically self-documenting.
You have officially upgraded your skills. Your toolkit is now packed with some advanced gear, ready for you to tackle much more complex problems, with real elegance and safety. So the only question I have for you is, what are you going to build next?